So, can you hear me on Zoom?
Yeah, very clear. Yeah, we can.
Okay then, so let's start. So I have a bit problems with my technical equipment here today, so I'm going to, my computer won't share my screen, so a bit odd configuration. So welcome to this course in scientific computing and Python and Fortran. And later on you will see how the Fortran language comes in very well with the Python code as well. So a little bit on myself first. So my name is Jonas Lindemann. I work at Lunar as a director, but I also worked as a researcher in instructional mechanics. I've been programming computers since the 80s, a lot of different computers here, until I ended up on the PC using Linux and Windows. I've been working at the university since '98. Civil engineer, buildings, roads, bridges. I have a PhD in instructional mechanics. And I worked at Lunar since 2004 approximately, first as a system engineer building high-performance computers, and then in 2009 as technical director, and now I'm director for Lunar as well. So I'm a bit of a scientific computing nerd, so I like programming computers, and both for computation but also for creative purposes. I have been working with many languages. So I started off at Object Pascal. Before that, I was BASIC as well, but Object Pascal was my first real serious language. Working with C++ since the 90s, Fortran since 98, Java bits, not full time. Python since 2003, just after my PhD. Processing is a Java-based creative programming tool, and very little JavaScript as well. I've developed a lot of library applications for structural mechanics. Most of them in C++. So ForcePad is a 2D finite element application. Objective Frame is a 3D. I've developed some useful tools for converting Fortran code to Pascal, connecting Pascal and Fortran. I've done a three-dimensional scene graph library called IDF++ in OpenGL. What I currently work on as research is the CalFem finite element toolbox, which I have ported to Python language. So I have this Python. We have a MATLAB version of CalFem, and we also have a Python version of CalFem. And some other libraries here that I'm working on. If you're in user of Lunar, when you start using desktop, and if you use the on-demand desktop, there is a small dialog bringing up where you can start your applications on the back end. That is the GFX launcher application, which is written in Python and can handle the launching of applications on the back end of our systems. We also have a tool called ML Browser for browsing the module tree on Lunar to find software. It's also available on the menu. And then I have also been involved in a commercial finite element code called Hopcom, which is not sold anymore, but we distribute it for free as structural mechanics. And then some other, we have what you're going to see later in this course, Qt Creator Fortran extensions, which is a way of creating a Fortran development environment for the Qt Creator development environment. Yeah, some other stuff here as well. So the course itself. There are several modules here. So today I will go you very quickly through Python, the base language. The next module will be matrix computing with Python. And we have lectures and seminars Monday and Thursdays. Seminars on Thursdays, but in the beginning there will be lectures, mostly the first course. Plotting with Matplotlib, built-in functions and I/O. use the library that comes with Python and how you use that to load different files, both binary files and text files. An introduction to object-oriented programming in Python. It's an overview because that is a subject in itself, object-oriented programming. So I will not go too deep in it, but it's very important because Python is very object-oriented. Everything you do in Python is an object, and there are methods on it. So it's good to have this overview of what the concepts are. We'll go for data processing visualization. Okay. We will go for user interfaces using something called Qt, which is a user interface toolbox. But this year we will also have the option, if you would like to go web, I will also go for another library called Nice GUI, which you can very easily, similar ways to Qt, create web applications that are interactive. Fortran, of course, will be 2 lectures on Fortran and also mixed language programming. So Fortran can be seen as an accelerator for Python, so you can write your code in Fortran and integrate that into Python. And that's the main use in this course. I will only teach modern Fortran, so I will not teach any Fortran 77. We will use the modern syntax of Fortran. And there will be short assignments for each module. And then at the end, there will be a project assignment that should be, I will communicate that so you can think about already now, something that combines the things in this course with your PhD project. So it's important that it's integrates with your own work. As I said, lectures on Mondays and tutorials on Thursdays. The first weeks will be more lectures on Thursdays as well. I hope everybody has got into Canvas. Good. So in Canvas, I will show you, there is a link to our course webpage with all the information, all the assignments for the course. So course administration is through Canvas. I will send everything out on Canvas. So if you course announcements and everything will go through the Canvas interface. And also assignments will be turned in through Canvas. And also I will try to answer, if you have any questions that come up, there is you can contact me here or via my email, jonas.lidemann@lunar.intelligence as well. But there is a way of communicating inside Canvas as well. Yeah. And also this is, I have been told to tell you this, that you submit your own assignments. It's not allowed to share source code and files. You can talk together, but sharing of source code is not permitted here in this course. Course literature. So the first link here is the course page where you will find links to the lectures, also all the programming assignments. There is also a link to GitHub with all the source code that you will use in this course. I have published everything now, so you can work forward, but it could be that I will change some stuff on it a bit later on in the course. So, but most of it will stay the same. And there are also some links to some other useful resources on the web. NumPy guide. There is a book here which I have written in Swedish, unfortunately, a Studentlitteratur Ingenjörens Guide to Python. It will be translated later this fall to English as well, but that is not the case currently. But are you learning Python, programming Python, the second edition, Python scripting for computation assignment, which are recommended. It's not mandatory. Yeah, I think most of the things in this course can be you can learn from the web pages here in the beginning, and also my notebooks. A short about Lunar as well, because if you have an account on Lunar, you can do the course on the Lunar resources as well. So I have in the course documentation here, there is instruction how to load an environment on Lunar from the remote desktop environment on Lunar. And just short what Lunar is here. So we're a Center for Scientific Computing. We provide high-performance computing resources at Lund University. We have training, education. What you're doing here, we collaborate with compute. And we have an environment for performing scientific computing. So we have an interactive HPC environment where you can log into, get a desktop, you can submit jobs. We have something about 300 compute nodes for running scientific codes. And I think this is a number. I think we have 1,100 software packages that you can use. So we have a lot of pre-compiled scientific software available. So you don't have to compile it yourself. Yeah, you can log into this page to look at this. This is the environment we provide. So you can do graphics here as well. So the first thing in this course here, if you're not familiar with Python, is getting familiar with how you can run Python. So how you use your Python in your preferred environment. So many ways of running Python. The one thing you can do is install the Anaconda Python distribution. It's also available on Lunar, so you can use that. So it's like MATLAB, but for Python. It contains all the modules that you need for scientific computing. It also has a development environment. So prepackaged Python distribution for scientific computing. You can download it from anaconda.com. It's free. And on Windows, it will create shortcuts for starting an Anaconda prompt on Windows. So Anaconda prompt is a terminal where you can type Python, and there you can access the Python environment interactively. Also, if you're running on Mac OS, it will modify your environment to replace the default Python, because the Apple computer comes with a Python from the beginning, but it's really ancient. So it will replace the Python with the one that comes with Anaconda environment. So to access the command prompt from Mac, you need to open a terminal in the Mac, and then you can type Python and access the environment. On Linux, same thing, it modifies the environment you can access the Python distribution from there. And then Python can be run in multitude of ways. And the first one that is the terminal. So basically, you type Python, and then you can type a file for Python, for example, a source code file, and the Python interpreter will execute that code and exit. If you type Python and just press enter, you will get an interactive Python prompt where you can actually enter Python commands and enter variables and experiment with Python interactively. You can, in your Anaconda prompt, you can type spider. Then you will get a MATLAB-like interface where you can run, edit your Python code. You can run it, you can debug it, and do most things almost like MATLAB. You can see here in this part here, you will get the variables that are active in your environment as well. My recommendation is actually to use something called Visual Studio Code, which is available on both Mac, Linux, and Windows. It actually provides an excellent environment for Python code. So if you install the Python plugins, I will show you just in a minute here, you can run your Python code. It will recognize the Anaconda distribution. You can select different environments and run your code from there. You can even debug your code step by step. The third way you can run Python is in something called notebooks. And that is what in my lecture here after this, I will go into a notebook. And a notebook is a combination of text and Python code. And you can execute your Python code and it will show up in this web page. And most of my lectures will be in notebook form. And there are links to those lectures on the course page. And there you can follow along my lectures live if you want. And I encourage you to do that, to have your laptop and follow along. So that is the 3 ways you can run Python. There are a multitude of more ways, but these are the main ways scientific computing. So I have a small experiment I want to try with you as well today. I want to see about your background here. So let's see if I can do this. If you can open this on your phone, you just open menti.com, and then you enter that code there. Yes, we have one connected here. Oh. So now you can enter some text here. So just enter what science areas you are involved in. You can have multiple as well if you want to. No. Yeah, it's a mix of different. We have everything from psychiatry to fluid mechanics, building services. Yeah, cool. Then we have what programming language have you used before? It can be just use it. Yeah, I used it a little bit or more. It doesn't matter. Just kind of what you have tried. Yeah, basic. JavaScript as well. Okay, I think we have covered most of those. Oh, there's more. Then we have a final question here. Is just a short note what you would expect, what you're expecting to learn from this course. Very high level. Okay. I think we should cover most of these things here. I hope. So, thank you for answers. I will try to do some more of this. Also, may able to comment on the course as well after the lectures, for example. But I haven't memorized too much yet. But I'm trying. So let's just look at the Canvas page. Let's see if we can go back. So this is the main page here. You will see here the modules here that we'll be going through. So the course information here is a link to the here you also have a link to the main web page that contains all the assignments and documents. I decided to separate it because it was easier to manage for me. So let's open this in a new folder here. So this is the course page with, here you can find all the lectures. And I will put up a playlist here of the recorded lectures as well. Here you have the lectures here, the notebooks. And if you click on those, you will get into the notebook. I will show you shortly how that works. Here you have a link to the GitHub repo with all the source code that you can use in the course. So all my lectures and all the things that I've shown will be in here, so you can look at it and use it yourself. You can also download here a zip file directly here if you want that instead. And then I have some links to useful information. And here you have the Python parts here. Here you can set up a Python environment. I will go through later as well. And here is how you set up the Visual Studio environment. So you find most of the information here, and you will also find Python exercises here. So these will be part of the assignments here. You can work them through one by one. I will only require you to turn in some of them, which I will tell you which one it's here. But there are plenty of exercises that you can try yourself here. And there will also be the same thing for Fortran here. There are lecture slides here, and there is Fortran course material. And there is a separate page for that. So if we open that, this is an online book of Fortran here that goes through the different things. We will use that in the course as well. So let's just show you the environment here for using coding in Python. So let's see if I can get that too. So I have opened a similar environment. Don't look at the compute environment here, because if you install Anaconda, it will say base, and you will get all the, you have the code available here. But if you open an Anaconda prompt, you will get something like this. Now this is a Windows machine here, but the syntax is the same. So what I can do now is I can do Python. If I do, for example, V here, I will show the version of the Python interpreter. So I'm using version 3.10. If I do just Python, I will get something like this. It's 3 greater than signs here. That's an interactive prompt here. So here you can, for example, define a variable. And then you can do, just like in MATLAB here, you can just show the value. You can do print statements here. And also, if you want to get out of this here, you press Control-C, and you are out of this environment again. If you have a, let's see if I have an example here. If you want to execute a source code file that you've written, I will come through how you do source code files, but here I have a lot of source code files. I have extension Python. If I want to run one of these, I can do simple 1.py. So Python is the Python interpreter, and then you give it the name of the file you want to run. And now it turned up on my other screen here. So this is the user interface window that's empty here. That is the Python code running. So that is the kind of hardcore way of running Python on the command line, but this is also the way that you will probably use it on a compute cluster or similar. Another way you can run it is using Visual Studio Code. And I can type, if I install this on Windows, I can just type code. Just code like that, or if you want to start from the directory you're in, you can do code dot. You can also start it from the Windows Start menu, where it works as well. So here is the Visual Studio Code environment. Let's see if I can make it bigger. So on the left side here, you have the folder tree where you are located in the, so where you started code, it shows up here. You can do the same thing here. If you started from the start menu, you can do open folder, and then it will start Visual Studio Code in that folder, and you have access to all the files in that. So if I do new file here, and I just do print hello Python. And then I save my file, and source code file in Python, they are given the extension .py. So I will do my file.py like that. Just save it somewhere. Let's desktop here. Now you can see here that it's colored. So now because I gave it the extension .py, it recognizes it as a Python file, and I can run it from here. And if you have installed all the extensions here, you have in the below part here, it should say base here, Conda in here. You can switch here if you have multiple environments here as well. We'll come through that later. And then I can type, you see here, if the extension is installed, you have a play button here. You press play. It opens a terminal and runs the code here. So you can see here, hello Python, like this. If you want to install the extensions for Python, you go into this box here and you search for Python. You can see here I have the Python installation, Python extension from Microsoft installed, and my recommendation is only install the Python extensions from Microsoft, because those are the ones that are most adapted and debugged. And you only need that I think this first one. There is, I think I have more here, but if you search here, there should be Microsoft Python extension, at least the first one here, debugging and stuff like that as well. And then you go back here, and here you can see if you start in the folder, you can open multiple tabs here, and you can get source code files here. So that is running using a development environment. You can type Spider as well on the command line to get the Python-like environment. Now it starts on this screen here, and I will move it over shortly. So this is the Spider environment, and here you have the Python editor here. And if you run code, the output will be shown here. Here you also have an interactive prompt here that you can enter code here, just like in MATLAB. And if you run your code here, it will show up variables here. So you have variable explorer here. You can see that I have declared a here, which is an integer, and 42. And if you enter the code here, you can do print and here it says that you can run with in the current Python environment here, and then you run and you see it executes here. So that is the third, and then I have a fourth way of running Python as well. You can run something called a notebook, I showed you before. And if you want to run it on the command line on your own machine, you can do Jupyter, and you can put notebook. And here you have the basic interface here, and you can do new, and then you say Python here. And here you have a basic notebook. You can give it a name here. I'll save as here you can enter either code like A equals to 42. You press Shift Enter. That executes that code. You can also do run, and you can also press this button here to execute code. And if I do A here, I'll just press this one here. You can see here that it shows you the output directly here. I can also add insert a cell below, and here now it's still a Python prompt here, but I can change it from code to, for example, a heading here, and then I can enter and then you press Shift Enter here, and now you see it turns into normal text here, and I have a code again, and I can change to Markdown here. You can enter any text here. You can also do, sorry. If you want to edit again, you just double click it here, and then you can do bulleted list here as well. And here you can combine code execution with text here and save it. So, and then you can send the entire notebook here with instruction how to execute to somebody else that can open the notebook, go through it step by step, and execute the code. And I will show you later, you can also do diagrams and plots and image viewing in the notebook as well. So this was a notebook, and if you lose the access to the notebook, so for example, I clicked down these ones here. If I go back to, you can see here when you start it, there is a link here in the beginning. So if you want to connect back to the notebook, you can click here. You should be able to, then you get back to this link again. It's also possible to do, but if you want to exit the notebook now, you press Control-C, and then you're out here again. There is another notebook variant called Lab, which is more a full-fledged development environment. So this is more like Visual Studio Code, but you have, here you can see your files here, and here you can start different, you can actually open a console, you can open a notebook like this, and it will be shown inside here. And you can see here that I have my notebooks, the one I created here before, and this is a new one here. The final one I'm going to show you now is from Google. So if you go into my, let's see, I'll close this one here. So this Python lectures, and you click on Introduction to Python here. That will open a notebook in the Google Cloud. So Google has an extension called Colab, where you can create Python-based notebooks. They are not the same exact like a Jupyter notebook, but almost. And what you need to do if you want to be interactive with it, there is a folder here now. It's already running here for me, Anslut, and it will allocate a Python interpreter in the cloud for you, where you can work. So now I have opened my lecture Introduction to Python here. There is on the left side here, there is a table of contents that you can follow along. There is a search, there is variables, and it's also a folder here. So if you have Python code that creates files, they will show up in this folder section here. So here you can see there is sample data here, but it's empty here. But if you write the file, it will show up here. And here, if you want to use those files on your own machine, you need to download them, because it's when the notebook goes away, the files also disappear. So you need to download the things from the notebook before you close it. So let's start with a Python talk here. So now I'm closing this one here. So a little bit about history here. So Python was created by Guido van Rossum in 1991. So it's not too old language, but it has some years to its history now. And what he wanted was a language that supported code readability and also to be able to write large application in a very clear style that it's easy to read. And you will see what code readability means. In other languages, you have curly brackets or begin, end, or something to describe the structure, but usually you also indent by yourself. But it's not required in C and C++ format. Indentation is not, it's something you do yourself. In Python, indentation has meaning, and you will see what that means shortly as well. So you need to actually format your code in a certain way with indentation to define blocks and structures in the language. It's dynamically typed. I will go through this later on, but basically you don't have to declare a data type when you declare a variable. The variable will be, if you assign a value to the variable, it will get that data type that the value has. So, and also a variable can change the data types that this points to during the program execution. This is something that is perhaps a bit uncomfortable for people like me coming from C++ or Java, which are strongly typed languages, where you always have to declare a data type. But it's not untyped, which is also something that people mix this up with Python. Python has very strong types, but the data type can change during the execution, which has benefits when you code. It also supports many different programming paradigms. So you can code structured procedural, defining functions and modularizing your code in that way. You can do extremely object-oriented code, but you can also do functional programming. So it supports all of those in the same language. So as I said, Python 1 was released in 91. Python 2 was released in 2000. And then we had an 8-year pause between versions, and they released Python 3. 3 was actually not, they did a break from the previous versions to Python 3, so it actually removed some parts of Python that was not very, it was a bit unfortunate syntax constructions. So it broke compatibility. There is still a Python 2 version because it has been used in so many applications and libraries that it's very hard to deprecate. But it has been deprecated now, so they will not release more version than 2.7.18. But that's the final Python 2 version. And I think the latest version of the 3 is now 3.11.4 or something. And by default, I think Python and Anaconda version will install 3.10. There is no big syntax things between these versions, so and we will not be that bleeding edge in this course. Also important to know that the main Python page is python.org. And here you can also download a Python version. Okay, yes. So this is the main Python page. So if you install this version of Python, you get a very rudimentary standard Python. So it only contains the parts that are part of the Python language standard. So there are runtime libraries built into Python, but that was part of the Python standard. And it doesn't contain any numerical libraries at all. So you have basic numerical scalar types, but there is no array types or no matrices. So for that part, in this course we use Anaconda. There are some other distributions as well that you can use, but this is one well-known distribution that contains most of the. Yes, we know this is new. So this is the Anaconda homepage, and here you can download any versions you like of Anaconda here. And it's free for students and also free for use in academics. So that's Anaconda. So the philosophy of Python is that beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex, and complex is better than complicated. And also readability counts. So you will see here that you're forced to actually write readable code. It's very hard to do it another way. Of course, there are some certain things you can do in Python as well that it's completely unreadable. But if you code normally, you will get the structure of the code will be defined automatically. So program structure, Python programs are text files usually that contains rows of statements. So and the text files are translated into computer instructions by the Python interpreter. So in many other languages, you compile source code to object files that you link to an executable. So you translate to machine code everything. In Python, the Python interpreter translates row by row. But that's also why you can use it as an interactive language, because you can enter commands one by one. Empty lines are ignored, and usually the Python files have a source code extension .py. And also the text, they are called source code files. And this is a typical Python source code file. So usually you have this part here in the beginning here. This is something that's mostly used on Linux and Unix environments that tells the shell that you're executing which Python to use. It's not mandatory, you can skip that. This is rather important here if you are using international characters in your code. So if you want to print Swedish, for example, with you need to tell the interpreter that I expect international character according to the UTF-8 standard. It's also optional, but if you don't put this in, your code will have problems when you get to an or some other international characters. Comments are these brackets here, and they will be ignored. Then you have statements here. This is a for loop, which we go through later. And you see there is a colon here. And when you have a colon at the end of a row, that means that Python should expect a code block. So it's the same thing as starting a curly bracket in C, for example. But here, then you need to tell the Python interpreter the code block by using an indentation here. So here I have 4 characters here. So print statement is indented. That means that it belongs to the 4 statements code block. And all the statements with the same indentation will also be part of that code block. So indentation is important in Python. So indenting something, that is a code block. So let's run our first Python code here. So print statement is prints a variable. For I in range, this is a list of 0 to 7. And I then will become, for each iteration, it will increase up to 7. So range will not include so we start from 0. So most of the functionality of Python is provided as functions. So Python has a large runtime library for printing, numerical functions, string manipulation, file management. A function is called by giving its name, followed by a list of parameters within parentheses. So it's probably very similar to many other languages. Here is a print statement, which is a bit special because it can take multiple parameters, so dynamic number of parameters. In this case, we have a string and we have an integer here. And it will print out like that. And some functions don't have parameters, but you still need to specify the parentheses. to indicate to Python I want to call a function. So in this case, you have a print statement that will just print an empty line, and I give it an empty parenthesis. Also, all functions in Python can have return values. You don't have to have them, but they can take return values. And you assign a return value by providing a variable equals to and then the function here. Very similar to MATLAB or any other languages. What is a bit special compared to, for example, C and Fortran, you can have multiple return values. And then you have to list them on the left side of the equal sign here. So Q and R, div mod, and then the function here. Div mod will assign both of these variables to values. So storing references data, this is a fundamental feature of a programming language, to be able to reference data in memory in some way and to pass data around to different functions. And in Python, variables are always reference. They always point to a memory location somewhere. So you can have multiple variables pointing to the same data array, but it works like you expect it to. So in this case here, to define a variable, you just name it and then assign it a value. And here b equals to 15. And now these variables will be integer variable because I gave them an integer. Floating point, you use a decimal point to indicate that this is a floating point variable, and C and D will be floating point variables. And you can have E equals to, and then a string, which is denoted by quotations or single quotes that will be defined as a string. So E is a string variable. Lists can be composed just by using the square brackets and giving it a number of elements that you want to include in lists. So here we've got integer, 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 and then a string. So lists in Python are very flexible. They can contain anything. It can contain other variables, you can have other objects, and you can contain them in a list. And now you see here, I can do a equals to string here. So I had a here, first it was an integer, and now it's a string. So that is perfectly okay to let variables shift the data types that they're pointing to during the code execution. But there's still, this is a distinct integer, this is a distinct floating point, and this is a string. So you don't have a, they have to have a data type. Variables can be named. The rules are that you can only use letters from the English alphabet, numbers, special character except no special character except for underscores. So you can't have a dot in the middle of a variable name. They can't start with a number. They have to start with an alphanumeric character. And variables are case sensitive. So allowed variable names are first name because we have only alpha character, and then have a special character underscore. Last name is okay. Number I2 is okay because it starts with an alphanumeric character. These are not okay because it starts with a number, and you're also not allowed to have Swedish characters or international characters in the variable names. It has to be part of the English alphabet. Perhaps we should take a 10 minutes break, and then we continue. So, okay. So more on variables. So I touched upon before that variables in Python always references to the underlying data. What that means is that when you assign a variable a value, there are 3 steps happening. Memory is allocated for the value to be stored. So there is a memory somewhere in your computer. And then a variable reference is created, the variable itself. And then the variable reference is assigned to point to this value. So if you look at the following code here, we have A equals to 42 and B equals to 84. you can see here that in memory it looks like this. So we have A here that is a variable reference that points to the memory location here in gray, 42. We have B that points to memory location 84. So two variables pointed to two memory locations. So what happens if you do A equals to B? In many languages, there is a copy being made, but in Python, there is no copy being made. You see here, always here that so A equals to 84 and B equals to 84. But in memory in Python, it's not really as you would expect. So this is what it looks like in memory. So there's no copy being made. A now points to the same memory location as B points to. So A equals to B is not the same, it's not a copy. It's an assignment of references. And in almost 99% of all cases, it works like you expect it to work. But it's good to have this in your back of your head that variables are references, because it will be more important when we come into lists and when you have variables that are contained in lists and other that contains points to variables in a list. So, and also what happens to 42? So in Python, when memory is not used anymore, there is no variable pointing to a memory location. Python will automatically delete that memory. It's called a garbage collector. So it's collected with the garbage and removed. So then we can do like this. We can assign. So in this case, A already exists, and we assign A to 21. Now you can see here that A does not point to B anymore. It points to a new memory location. So here we created 21, stored it in memory, and we let A point to that value instead. You can check this, how it really, if you want to see what the actual memory location is of a variable, there is a function in Python called id that will return a reference to that variable, and you can see if they are the same. So in this case here, we do the first setup here, and we print the IDs of those two. We do A equals to B, and then we print ID of those two. And then we do this one here, just to kind of compare what happens when you assign variables. So you can see here that, let's see if we can get it to the same page here. In the first case here, you have two unique IDs. There are 224 and 568. Then we do A equals to B. Now you can see here that both of them points to the value store that B has from the beginning. So 568, 568. And then we have A equals to 21. Now you can see that A changes its reference to 552. And B still has this 568. So if you're unsure, you can always use the ID function to check this. But normally, you don't have to think too much about this. Is in certain cases, for example, if you're using lists and arrays, where it can be a bit tricky with the references. So data types in Python. So I will just go through quickly here what data types are in Python. Even if you don't declare them, they still exist. So as I said before, integer floating points depend on what you assign here. So if it's a scalar or literal here, it will be a scalar integer. And if you have 42.0 here, it will be a floating point variable. Python also has operators, like most languages. You have exponentiation here with double stars. You can negate a variable using a plus and minus operator in front of it. You have multiplication, division, floor, and modulus. So doubles, this here is a floor, and this is modulus. Addition and subtraction, comparisons. So this is equal to, not equal to, less than equal to, greater than equal to. And then you have logical operators here, is not. You have Boolean not, and or. And also the evaluation order is in this order here. Yeah, and you can create expressions like this. And also, if the expression is a floating point or returns, it will take the highest and return a floating point. This was not the case in Python 2. Python 2 would do integer divisions here. So this is something that was changed with Python 3. This, for example, this expression here would do an integer division here. Now Python 3 returns a floating point. There is also a built-in floating point. No, sorry, a Boolean data type. And there are special predefined symbols for indicating true or false. So C equals to true with an uppercase T, it's important. That will be a Boolean variable now. And you can do false with an uppercase F as well. That is also a Boolean variable. So if you try with, for example, we can try false with a lowercase here, just to try out. Now Python don't like it. So now it thinks that false should be a variable that is not defined. So false with an uppercase is the special meaning here. And here you can also see the notebook way of handling errors here. So if you run a notebook, you will actually get an error here that you can read and interpret. So let's run this again. Now there's no error. Another data type that's important in Python is lists, and also very flexible data type. So you can, because lists are can contain any data types, they can also contain other lists. So you can create nested data structures. I would just warn you that lists should not be used for array computing. It's a heavy data type. It's flexible, but not to be used for millions of items. So just think about that. So, but for small things, it's very useful. So here you can see here you can create an empty list by using an empty bracket like this. That's an empty list. You can define predefined variables, data that goes into the list by just listing them here. So I have 4 integers here, a string and a floating point. So you can see you can mix both integers and floating points in a same list. You can access the different items in the list by using brackets, and lists by default are 0 based. So the first element is always 0. So here you can see values 2 here, that is 0, 1, 2, that is the 6 here. You can change values by just reassigning the value in the list here, like so values 4 equals to hop. So this is 0, 1, 2, 3, 4. So this string here will be changed if we do this. So again, I changed this item in the list now. Another nice feature with Python list is that they start at 0, but you can also give a negative index. And a negative index will wrap around. So -1 will be the last item on the list. So it goes around. So this will return 1.0 here, which is the last element. And you can continue with this. You can do -3, then it go from the list and back 3 steps. Quite useful. If you try to access the list outside the bounds here, let's see if we can just add here code. So also, if you try to access a list outside of its bounds, which is defined in, you will get the list index out of range here. So the program will fail if you access them outside the boundary. So, and now when it comes to lists, it's also important to talk a bit about variable references again. So a list consists of references to data in memory. So data is not stored in the list, but in memory, and the list points to the data locations here. So just like before, we have values here, that is variable pointing to a list. And you can see every item in the list is also a references to data in memory. So what you can do then, just to kind of illustrate, so I have this list here, and I assign B, which is a new variable reference, the value at position 4 of the values list. So 0, 1, 2, 3, 4. This is a string here. And then I just to illustrate here, I print the ID of B, and I print the ID of the values 4 in the list. So you can see here, hey, and you see that B now has the same ID here. So both B and the list here contains a reference to this string here in memory. And this can cause some trouble here. So yeah, this is the layout here. So B now points to this location here in memory, which also the list points to here. And in most cases, this will work fine. In other cases, it can also be that if you change the list item, or you can have problems with this. Also, let's see here. Yeah, you can also access the lists using index notation. So you can extract ranges of lists or sublists using colon notation here. So you put the starting value and the value that is up until but not including the 3 here. And you have here from the second position here, or 0, 1 to the last item here, or next last item. And you have 3 colon that will start on index 3 and go the entire list out. And this is kind of obvious. You put the colon in the list, you get every item in the list. -2 range from 0 to len minus values -2. And then you can go from -3 forward, it wraps around. So let's see here if we can run this here. So I can now extract sublists to these different lists here. And here you can see here the position -1, -2, -3, -4, -5, and so on to the list here. And you can see here the ranges that we extracted from the different arrays here. If you work with list use, if you get a list in a function, you probably will need to, at some point, query the length of the list. And in Python, there is a function that is used to query the length of any data structure. So the len function here is used to query the length of any data structure. So it could be a list, it can be a dictionary, which we'll come to, another data type string. You use the same function to do multiple different operations. So in this case here, if I do print length values here, you see it returns 7, which is 1, 2, 3, 4, 5, 6, 7. There's 8 here. I missed a step here. Must have removed it. Yeah, okay, but it should have returned 8. Let's see if we can start over again. It's 7 here. No, it should have returned. You can add values to lists. There is a special method here, and here you see the object orientation connection here. Every object, every variable in Python is also refers to an object. So values here, it's a list. It has a certain number of functions attached to it, or called methods, which you can use to modify it. So append here will add a value to the list. So it added 42 here. You can also use the insert method here to insert at a specific location. So insert after 1. So it inserted from the position here at 1, and then it moved all the other ones up here. You can use the remove method to remove items from a list. So here you can remove a named item here. And you can see here, it shows you before and after here. So before is this one here, and now the squeeze text is removed. You can also use the del method, which is a generic function for deleting elements in different data structures. You can delete, and then you specify the list and the index of the list that you want to delete. So now I removed the first item here. So 1 was removed, so now I have 3 in the beginning. You can also use index notation here as well to delete ranges of lists. And there is also a method to be able to use the list as a stack-based data type. That is a data type where you push and pop from the end of the data structure. So here you have a pop method here, and that will assign that method that it removes from the list here. So let's see what it does here. So we have value 364, and then I pop, then it takes the 4 and removes that from the list and returns that to the V value here. It's also possible to clear a list. So if you assign, you can do it in different ways here. But so, for example, if you have A equals to, you can just assign an empty list. The reference here contained in the list will still exist until the garbage collection will run. But the thing is that if you do like this here, A equals to 46, this list here, and then you do B equals to A, and do A equals to that, you can see here that B still exists, or the list still exists, but B points to it now. So this doesn't actually clear the list. It just removes the it creates a new list which is empty and leaves the other lists in memory. If you really want to clear a list, you use the clear method. So in this case here, I do A equals to list, and then do B equals A, and then do A clear. And that will also clear B, because B points to the same list. So clear is, if you really want to clear a list, you can use, it actually removes the items. If you just do an empty bracket, it will create a new empty list. But the old list is still there if there is a reference to it. Oh, now we do it more complicated. So, as I said before, lists can contain any data structure, so it can also contain lists. So by containing lists, you can do nested structures. So in this case, you have A equals to 1, 2, and then I have a list contained in A that is 3 and 4. And then I have 5 and 6. So this list contains 1, 2, 3, 4, 5 elements. And if I print out A2 here, I will get a list printed out here, 3 and 4. You can also access the into the inside list by using an additional bracket operator. So in this case here, if I want to access the first element of the second element in this list here, I can do 2 and then add a bracket to access the number 3 here. If I access number 4, I can do 1 here. So like that. So in this way, we can quickly create two-dimensional data structures. So I have an example here. I want to create a spreadsheet like in Excel with a lot of data. I first create an empty list that will contain my rows. And then I do append for each row. And here I do a trick here, which is kind of interesting here. So if you have a list and use a multiplication operator, it will create 10 elements of 0 in a list. So this here is actually a list with 10 elements of 0. And then I append those to this spreadsheet. I print it. I ask the length for a spreadsheet. And then I can access the spreadsheet by specifying the row here, 0, and element number 5. So let's see how it looks like. Now you can see here I have the list here containing multiple rows of 0s. And you can see here there is only 4 elements in the top list here. So, and then there are, inside each of these elements there are 10 zeros. And then I can access row 0, element number 5. It's kind of useless here. It's also 0 here. But then you can have this double bracket notation. And I can show you here what it actually means by using the multiplication operator. So here you can see I have, this will create a list of 5 elements. If I do 6 here, it will do 6 elements. So this is a quick way of creating a list with a certain number. So as I told you, it's important with references Python. So in this case here, I have 2 lists. I have B equals to 3 and 4. And then I have A that is 1, 2, B, 5, 6. So I add B to my A list. And then I try to change the B 0 item to -1. And guess what happens to the A and B list now? So you can see if I change in B, the A list will also be modified. So in some cases, this is what you want. In other cases, this is not what you want. And if you do not want to, yeah, I can show you the illustrated picture here. So this is what happens here. So you have A that contains a reference to B here. And if I change B, of course, it will change in the A list as well. So what I can do, if I don't want that, but I want a copy of my list inside A, I can actually use the method called .copy. That will create a new list that is a copy of B, but it's a new list. So if I run this here, you can see here, if I change B now, there is no connection to the list inside the array, the list here. Yeah.
A vote. Doesn't matter when you change B, why does A not change?
In this case here.
So like when we have on A list and B list, we set A is 2. And we change the B, for example, as a different list with an A dimension. A just stays as a copy of the former list.
Yeah. So now I create new. In this case here, I create a new B list. But it's a new list.
I think it was variable, right?
Yeah.
Right, when we had that earlier when A. Oh, maybe yeah. I was also wondering because before it didn't update.
Because every time the only problem is actually when you have these lists that references to lists. That's when you have the real danger of these references. But if you have normal variable, usually you can't have cross references, because if you do A equals to 42 and you B equals to A equals to B, and then you do A equals to another number, it will be replaced. But in this case here, we are working with lists which can be changed internally. And so in this case here, here I create, so B existed before. Now I create a new list here. And in this case, I create a new list inside here that is a copy of B. So if I change this one here, nothing will happen inside A. But I could do the other way around. If I had another example here changed A, it will also change B. So in this case, if I had instead changed so I would say A 2 or 0 1 2 2 1. So you can see here that other way around, I can change A here and it will change B because they point to the same things. This is the kind of construction here. They point to this is the list that is contained in memory that is in the same location. B points to it and the list points to it. But if you then do this one here, you get this here instead. And then you get the copy here. So the list points to this copy of B. So it will be duplicated. Yeah. Sorry, it's a...
If you have the situation that you change the Well, maybe point is something completely new with the modifying. Then get this copy to the pointer is memory where the other original view is, even though we don't use the actual difference in the variable B.
Yeah, every time you do this, you create something new here.
Yeah, but we would say B is deleted off of parentheses.
Yeah.
Then you could tell B to be something else after the line 2.
So if I remove this,
Then you line 2, you just say B. Oh, something else.
yeah, then you can do the same. Yeah.
Then A will contain still a point with the values.
Yes, so you can do like
Instead of changing a value,
you can do like this, and then you have C that is a copy of B, and now the only reference is or you do like B equals to then now you create a new list, and this one will be kind of stuck inside here. The memory location of this will be in this list and contain. So you can do it multiple ways, but you need this copy to be able to do a copy. Or yeah, in this case, you create a new list that you continue working on. Yeah. Just now need to not change my code here. Copy. So this is what you do, but so it's not, you don't have the access, it's reference variables instead of pointer variables. Okay, then we have some final ones here as well. We have a data type called tuples, which is a special form of list. It's always ordered, and also you can't change it. When you create a tuple, it's always fixed. It's immutable. And instead of brackets, you use parentheses when you create tuples. And the benefits of that is that the iteration on tuples is faster than lists. But they basically work just like lists, so they are very similar. So if you do like this, you can access them using the bracket notation. But if you try to change it, it will complain. So you can't assign something. You create it, and it's a read only. You can't append either. But it's really a very weak restriction, because you very quickly can create a new tuple that has another element. But then it's a new tuple, so every contained tuple is immutable. But you can create new ones. So for example, this one here, you have a tuple here, and you add on, and then you it can add a number like this. But what you do here is that you create new ones, new tuples. So A here, the old one is still immutable, but it's very easy to create new tuples with addition. But it's not something you usually do. So but the thing is that also when we come to this the other data type string here, which is very similar to the tuple. It's also, all strings in Python are immutable when you create them, but it's very easy to create new strings from old strings. So strings, yeah, just string store sequences of letters, and it's if there's one thing that you can do multiple ways in Python is strings. So there are I think 3 or 4, 5, 6, 7 different string types. We'll go through some of them here, but also, as I said, with the tuple here, strings cannot be changed when they have been created, which sounds like very restrictive, but it's really not. So the easiest way of doing a string is by using double quotes or single quotes. If you need a certain quote character in your string, you just surround the string with the quotes that you don't need in the string, like this. Or if you need a double quotes inside, you start with a single quotes outside. But you can also, if you really want to use a certain quote, you can always use control characters in the strings to add characters. So if you want a single quote in a single quoted string, you can do backslash single quote inside here. You can do backslash double quote. You can do backslash n, which gives you a new character, a new line in the string. You can do backslash t, which is tabulation. And if you want a backslash, you can do backslash backslash. So strings in Python are processed when they are assigned. So in this case here, I have full name here, and I have a backslash n here, and Python creator. So if I run this, it will print out the first line here, and then break line here, and the next line here. So this is a way of creating strings that also can have formatting. But sometimes you really don't want processing of strings. You really want the string to contain these backslash characters or backslash or anything. Then you can add a prefix here. It is not the wrong syntax here. You put an R here, which stands for raw. And that R will prevent Python from doing any interpretation of the string. So in this case here, if I print this, it will print the backslash n, but not do that with a standard string here. So you can see here, this will print it just like it says in the string. And here it will have a backslash n, which will be a new line and go to the next line here. So this is a way of preventing Python from doing interpretation. Then there is another really cool way of actually specifying strings with formatting. I call them triple quoted strings. So you have 3 triple quotes here in the beginning of a string, and then you write the formatting just like you would in a text editor. So in this here, I just break the line here to the next line. I continue writing here, I have a break line here, and then I end with triple quotes again. That will preserve this formatting. So the string will contain new lines and formatting codes, just like it's written in the variable definition here. So if I run this, you can see here I get three lines here. Yeah, I don't get this in the beginning here, but this starts here, and the formatting is done like it's in this here. And what you can do is, for example, if you have input files to your computational code, for example, you can put them in triple quoted string, make a template of your configuration file, and have variables to replace inside a string and write that to disk. And then you can have a nice templating functionality in your code directly. So it's very nice feature to have. Triple strings are also used in function documentation. So if you have a function and you put a triple string and a text, it will be documentation for the function as well. Length of strings is the same thing here. You have the length function to query the length of the string. Concatenating strings. So as I said before, it's really easy to create new strings in Python, even if they are immutable. So if I have these 2 strings, S1 and S2, I can just add them together using the plus operator, and then I have a new string that is a combination of these 2 strings. Also, as I showed you before, you can use the multiplication operator for strings and lists. And in this case, you can really easily repeat the character, for example. So if I want an underline of this text here, I can do dash and multiply by the length of the S1 string. And then I get a text that's underlined like this. So the multiplication operator can be used with other data types as well to repeat things. Another very cool feature, for example, if you're processing text files from data you have, the string is an object containing a lot of method that you can use, so you can tell a string to split itself. And what that means is that if you don't give in a parenthesis to this method, it will split on spaces. So this is a sentence here, and if I do split, I get the word list from this string. So now I get a list here with each word in the string as a string in this list. You can also add a split on, for example, if you have a text file containing comma-separated values, you can split on comma here instead. And now you can see here that you get strings of these values of the words separated under the strings that are separated by commas. You need to do some processing here to convert these to values. I will get back to that later, but this is a very quick way of splitting text. You can go the other way. Yeah, sorry. I think so. I'm not 100% sure, but I think. Yes. It's very useful. You can do multiple levels of it, split. And then you can also go from lists to strings. And this is perhaps a bit odd syntax. There is a method on a string called join, but you do it a bit backwards. So if you want to join, for example, this list of strings here with spaces, you actually tell a space to join the list. So this is the spacing you want between the items here, and then you do dot join, and then you provide your list, and that will create a new string separated by spaces. And if you don't want anything, you just do an empty string here, and it will join those together without spaces. So you can see here that you create, it adds spaces between the words, and then it adds commas between the parameters, the variables here, and then it just puts them together without any spacing like this. It's a bit backwards. You have to think, which separator do I want to join of a list? So yeah. It's also possible to search strings. So here I have a long, here you can also see that you can break lines in Python here using the backslash operator here, so you can have multiple strings. This is a long string, so it's not 4 strings, it's long string. And what you can do then, there is an operator called in, which you can query. So in this case, I can say, is the string vocalia in S? And if it is, it will return true, otherwise false. So there should be a vocalia somewhere here. Yeah, here. So that is a quick way of checking for existence of a string in a string. But there's also, if you really want to know where in a string the string is located, you can use the find method. So find will return the first position of the string of a given string. So in this case, I have far, and you see I have far here in several places here. And then I can do, it will just, first it will find it at position 4. Then I can add a second parameter here where it should start its search from, and then you find the next position. And you can see here also, if the string is not found, it will return -1. A very common operation of string is to remove leading and trailing spaces. For example, if you read a string from a file, you often read some spaces in the front of the line, and perhaps in the back. And there is a method on a string that's called strip, and the normal strip function removes both leading and trailing spaces. So you can see here, this is the original string, and this is the stripped string. If you just want to strip the right side of a string, you can do rstrip. You can see it removes the right side of the string, and you have lstrip, where it removes the leading part here. So if you're not certain of what data types your Python variables are, you can actually use the type function here to print out the different types. Not sure why it's here. I think it's a bit misplaced. Okay. So you can see here that it's possible. Python has very distinct types, and they are. This is are the type codes where you have int, float, bool, string. Let's see. The final data types we'll do today is dictionaries. So dictionary is a special form of data type where you store data in key value pairs. So every data value you add to the data structure will have a key, which you can make, which is used to retrieve the data again. And the difference from a list is that you declare a dictionary using curly brackets instead of straight brackets. And you can, by default, let's see how I do it. By default, you can add pairs by specifying first a key, colon, and a value, comma, key, colon, value. And it doesn't have to be strings. So the key can be an integer, the key can be a floating point, the key can be anything, and the value can also be anything. But you need to list them in pairs like this. So if you run this, you can see here that it prints out like this. You have Petra, it's the key. This is a value, so these are phone numbers, for example. And then you can access the values just like you would a list, but instead of having an index, you put the key in and you get the value back. So you can see here that David here, it has this number, and Peter has this number. It's very intuitive data structure to use. And it's also very quick to, if you want to search, you can very quickly retrieve values in this way, if you know the key name. You can also add keys by just writing values and then adding the key, providing the key, and then assigning a value to that. So it's almost like assigning an index to the list, but instead of an index, you have the key that you want to assign. And there is no check for an existing key. So if there is already a Peter key, that will also be overwritten. And you see here that I have a new key here. Finding values in a dictionary is also really quick. So you can use the same notation as we did for the string. So if Petra in index, it will return true. If Busse in index, it will return false, I hope. So you can see here. So you can very quickly check for existence of a key in the structure. And same thing for any data type in Python, you can query the length of the data structure using the len function. And that will return the number of items in the values dictionary. Adding values, as I said before, just assigning here. And dictionary can be nested with any data type. So a dictionary can contain other lists. It can contain other dictionaries. So you can very easily create quite complicated data structure. For example, this could be the configuration of something. So here I have a general configuration key, and you have an internal dictionary with username and temp path. I have another key called constants, and then I have p, pi, and j, which are internal dictionary here. And then I have a values key here inside here, which is a list. So then I can actually access the data type here, general username. So general username, constants, pi, like this. And you can add and expand this data structure. It's extremely flexible. So this was what I wanted to start for today. Next time we will go through loops, iterators and stuff like that. And you can continue if you want. The slides are available here. There are some tasks here you can do, which I will start with the next time we meet. Any question this far?
So what if you have a two structure? Like this also with the amount of cells in that matrix, or does it only give you like width or height?
So length will only return the outermost. So if you go to this, go back here. So if you do length on config, you will get 3. So it will only list the outermost dictionary. So it will not give you some information about the nest. You have to loop through yourself. And then we would have, we'll go through the array data types later. Those have more information about their internal structures than the dictionary. Okay. And see you on Thursday. Yep.